Okay, today I'm going to be teaching you guys how to cook with C++. Okay, so just as the preamble, have you guys ever wanted to do something really useful with your C++? Have you recently bought a $5,000 machine, but you really aren't feeling like you're getting all out of it? And finally, do you like scrambled eggs? Okay, well, if you fall in that category, we're going to need a few things. One, we're going to need a good grill. Two, we're going to need a good grill program. And three, we're going to need some eggs. Okay, so prepare the grill. What should we use for a grill? This is a big question, right? Especially in C++. Okay, well, we could use a good old cast iron outdoor grill, right? Some pros, it gets pretty hot. It's kind of cool looking. But it's not very portable, right? And more specifically, it's nowhere near as hot as a new 2018 MacBook Pro. If you need a reference, this is the best grill spot on the 2018 MacBook Pro. Okay, so now we have our grill. Great. How do we get it hot? How do we heat it up? We got to write a grill program. What constitutes as a good grill program? Well, tons of loads in stores? I don't think so. Multi-threading? Okay, yeah, we're getting there. Vectorization? For sure. And high flops or floating point operations? Definitely. Okay, let's start with a trivial grill program. Boom. Okay, got an infinite loop, some floating point operations, but just two. And this is actually executed sequentially. So I have this sensor program on my computer, and I read that my CPU is around 51 degrees, compiled with GNU compiler, and this is nowhere near as close enough heat that we need to grill eggs at, right? So maybe the next idea is we'll throw this into a parallel scheme. We'll parallelize this bad boy, and then we'll see if we can get some more heat out of this machine. Boom. Okay. Parallelized it. OpenMP, if you guys are familiar, one line, really sweet. So now, yeah, we have a ton more CPU utilization. Great. But our temp is still pretty low, 74. My computer has not been cooked yet. Okay, what are we going to do? This grill program still sucks. So the temperature to cook an egg is actually around 65 degrees Celsius. We're achieving 76, but we need to account for the temperatures. There's a lot of heat loss, thermodynamics, blah, 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 blah. And a big reason for this is we're not actually achieving peak flops. So let's do some math. Ooh, okay, so this is my grill. 2.6 gigahertz Intel processor. I disabled turbo boosting because then, the grill gets too hot. And my grill has support for AVX 256 vector operations. I'll be talking about that in a bit. Max flops can be calculated here. If I made a mistake, you can correct me after. So the max flops across 6 cores will be approximately 124.8 gigaflops, okay? So let's give this a go. Let's see what we can do. Okay, so this slide is titled How to Cook with Gasoline. First thing you gotta know, use intrinsics, okay? So AMD and Intel, a long time ago, they released these vectorized instructions that you can actually write in C and C++. And they're just as good as assembly instructions, but it's the convenience factor of writing in C++. So pretty sweet. And what a vector instruction is you can actually perform multiple floating point operations in one CPU cycle. So you can add 4 doubles, but you can do it in 1 CPU cycle. So really performant, and the CPU gets really hot. Okay, second, we can unroll our inner loop. So we can perform a lot more floating point operations before we actually get to that loop check. And then in terms of the intrinsics, we can perform fuse multiply adds, multiplications, additions, subtractions in this unrolled vectorized manner. Boom, okay. So this is my red hot grill program. So this is what an Intel vector instruction looks like. This MM256D is actually just 4 doubles, and you can load it in these special vector registers. Pretty sweet. And you can do some of these operations. You can look at the intrinsics guide online, but in 1 CPU cycle usually. And the benefit of this, though, is the computer exerts a ton of heat when you do something like this. So what I did is I just unrolled a ton of these vectorized instructions inside this while loop, parallelized it, and we got our CPU temperatures up to 96, and then I killed the program before I fried my processor. Not before the final product.